Okay, we've visualized our list of spike count data in two ways so far. We've printed out the number of spikes we observe in each trial and looked at that list of numbers. We've also plotted this list of numbers as a function of trials. So we've visualized the list of spike counts in two ways. As a third way to visualize a list of spike counts, we can create a histogram. And the idea is to count the occurrences of each value of n, or of each value of spike counts. And here's the result. Notice the axes in this case. On the vertical axis, we have the number of trials containing n spikes. You can think of this as counts. And on the horizontal axis, we have the number of spikes that we observe, which can range, let's say, from 0 to 30 as we've chosen here. We've put in a title on the plot, SNH, spike number histogram. And the question is, how do we actually compute this thing, the spike number histogram? And we'll go through this in detail. We talked a little bit about it in lab on Friday, but let's think about it in the context of this example. How do we compute a histogram of the spike count data? So to create the histogram, we can think about it as asking a series of questions. So we'll start with this question. How many trials do we observe with 0 spikes? And to answer that question, we can look at our list of spike count data. So here's the list of spike counts. We have the number of spikes in the first trial, the second trial, the third trial, all the way up to the kth trial at the end. And we look at this list and we ask the question, how many trials do we observe with 0 spikes? And the answer in this case is none. We find no zeros in this list. Of the 200 trials that we observed, none of them produced 0 spikes. And we can ask similar questions. For example, how many trials do we observe with 1 spike, or 2 spikes, or 3 spikes, or 4 spikes? And if we examine this list of numbers, we're looking for the values 1, 2, 3, or 4. And if we stare at this very closely, we'll find that no trials exist in these data that have 0 spikes, 1 spike, 2 spikes, 3 spikes, or 4 spikes. So the answer again is 0. So we're asking this series, we've asked 5 questions so far. How many trials have no spikes? None. How many trials have 1 spike? None. 2 spikes? None. 3 spikes? None. And 4 spikes? None. And we can see this by visually inspecting our list of data. All right, let's keep going. Let's ask another question. How many trials do we observe with 5 spikes? And again, we can look at our list. Here's our list of numbers. And if we look carefully at this, we'll be able to isolate some trials, in this case 4 of them, that have 5 spikes. So the answer in this case is 4. How many trials do we observe with 5 spikes? 4 of them, which we've highlighted here in red, these particular trials. Okay, we can keep asking this question. For example, how many trials do we observe with 7 spikes? Again, we can look at our list and we can try to count up the number of 7s. There's 1, there's another one. And if you keep doing this and you isolate all of the 7s that you observe in this list, you'll find that there are 15 trials that have 7 spikes. And we can keep asking this question again and again and again until we cover all whatever we think are the reasonable number of spikes that we would see in each trial. Okay. So to create the histogram, we repeat this questioning procedure over and over again. Do we observe 1 spike, 0 spikes, 2 spikes, 3 spikes, and so on, up to some maximum number of spikes? Let's call that maximum little m here. And we can start reporting these results. So we found that we observed no spikes in 0 trials. We observed 1 spike in no trials, 2 spikes in no trials, all the way up to 5 spikes we found was in 4 trials. And then we're going to go up to some maximum m. And in this case, we might observe m spikes in x trials. And we have to figure out what we're going to choose for m and x. And the purpose of choosing this m is that if we then ask, do we observe m plus 1 spikes? The answer we're sure is 0. What about m plus 2 spikes is 0. So we never observe anything greater than m. So we can choose this m in some way. And what we'll do is we'll just ignore all of these questions at the end where we know that none of the trials are going to have greater than m spikes. So we always choose m to enforce this. We never observe more than m, this little m spikes in a trial. Now, how do we know that we can do this? Well, there must exist a maximum number of spikes in a trial. We don't expect the number of spikes that we observe in a trial to go off to infinity. And why is that the case? Why can't we observe an infinite number of spikes in a single trial? Well, we can argue from biophysics that that's impossible. Right? Biophysically, we know a neuron cannot produce an infinite number of spikes in a finite interval of time. The neuron's restricted by biology. As we start developing models of neurons, we'll see that, for example, there's a refractory period after a neuron spikes, and it can't spike again after that refractory period. So we can use biological reasoning to argue that there must be a maximum number of spikes M that we can observe in a trial. And this list, once we've constructed it in this way, this list consists of all possibilities. So we haven't left out any trials. Any trial that we observe is going to have no spikes, or one spike, or two spikes, or maybe M spikes, but it'll never have less than 0 spikes. What does it mean for a trial to have a -1 spikes, right? That doesn't make sense. So we always start at 0, and then we go up to some maximum, and we know that beyond this maximum, we can argue for biological reasons, we will never observe trials with more than M spikes. So we've listed all the possibilities we could observe. Okay. So finally, we can plot these results, the results of this questioning of the data, and that's the histogram. So here again is the histogram. Note the axes, the number of spikes, the number of trials that contain N spikes on the vertical axis, and then the number of spikes, little n, on the horizontal axis. And we can compare this histogram to our questioning of the data. We observe 0 spikes in 0 trials. So if we look at the 0 here, the number of times, if we look at 0 spikes, which is shown on the horizontal axis, how many trials contain 0 spikes? None. How many trials contain 5 spikes? Well, we set n equal to 5, so 5 spikes. And we look at the height of this bar, and that tells us we have 4 trials. 4 trials where we observe 5 spikes. And in this way, we can construct the bars of the histogram. We observe 30 spikes in how many trials? Well, we look at the height of this bar at 0. There are no trials that contain 30 spikes. Okay, what types of things can we learn from the histogram? Well, there are many things we can learn from the histogram. For example, we can think about the maximum number of spikes we observe in any trial. So what is that? What is the maximum number of spikes we observe in a trial? And if we look at this figure, we see that there are maybe 1 or 2 trials that contain 22 spikes. Not very many contain 22 spikes, but that's the maximum number of spikes we observe on any trial. What about the minimum number of spikes we observe on any trial? So what is that? What is the minimum number of spikes we observe in a trial? Let's look at our histogram. We look at the smallest bin that has some counts in it, the smallest number of spikes that has some counts in it, and that corresponds to 5. And we see in this case, we observe 5 spikes. In how many trials? About 4. Now notice our axis, it has values less than 5. So why don't we say that 1 spike per trial is the smallest we observe? Well, we actually don't observe any trials that have 1 spike. Right? If we look at our histogram, how many trials contain 1 spike? None. Right? The number of trials that contain 1 spike in this case, this bar has no height, is 0. What about the mean? So what is the expected or mean number of spikes we observe in a trial? So if you were to pull a trial out at random from these data, how many spikes would you expect to observe? And a reasonable guess is somewhere between 10 to 15. About 10 to 15 spikes. We wouldn't be surprised if we were given a trial at random out of the 200 that we got 10 to 15 spikes.